Hello YouTube. So today we'll just be covering something simple. It's a partial differential equation. So a partial differential equation is basically when you have your solution like your u, and then it's differentiated with respect to only one variable. So here u is a function of multiple variables, not multiple, but like more than one variable. So it's not ordinary, and you're differentiating with respect to only one variable for some terms. So this case, this is a differential equation, the partial differential equation of constant coefficients, and the solution to this differential equation is actually not so simple. So we know that u is equal to f of bx minus ay, but what is f? Well, it turns out f can be any function as long as it remains continuous and fulfills has certain properties that allow it to be differentiated, but as long as it fulfills those, then it can be a solution to this equation. For example, we can have e to the I don't know, bx minus ay power. You could even square it if you want, for all that matters. Just as long as it can be differentiated and plugged back into here, then any function works, like cosine of bx minus ay. I don't know, sine cubed of bx minus ay. Sky's the limit as long as it fulfills certain properties that allow it to be differentiated and plugged into this equation. So let's just verify that it works. So let's take the partial derivative of x with respect, or partial derivative of this with respect to x and y, plug it in there and verify. So let's do that. So we get e to the bx minus ay squared times, okay, well, if this is u, then this will be u of x. U of x is going to be 2, or we're going to be finding the derivative of bx minus ay squared. This is the chain rule. This is just multivariable calculus here in action, times b times 2bx minus ay. Okay, so now let's try out differentiating it with respect to y. So this would be e to the bx minus ay squared. This time, if you differentiate it, it's going to be a times 2 bx minus ay. So if you plug either of these in, if you plug them into their respective positions in the differential equation, let's see what happens. So we have a times 2bx minus ay times e to the bx minus ay squared, and then this plus b times this, so a times 2b, or I could do b times 2a bx minus ay equals, or times e to the bx minus ay squared. And then if you add these two up, oh wait, sorry, this should be a negative. This should be a negative. So this would be a plus b times negative. Sorry, this should be a negative here because when you're chaining, you have this here. There would be a negative out here. So then when you add these up, it ends up as 0. So essentially, if you plug in any f of bx minus ay, it should work so long as it fulfills certain differentiable or differentiability and continuity properties. So I just thought that was some interesting tidbit for partial differential equations I would share today. Anyhow, thanks for watching.